So, hello everyone, this is lecture 53 for the mathematical physics. In the last lecture, we were discussing about the spherical symmetry. So, in spherical symmetry, we have seen that how we can find the area element, how we can write any vector in the spherical symmetry in the terms of AR, A, theta, A, phi. Okay, now today, let's see one more example for the area element in the spherical symmetry. We have this sphere and we have taken this cone out. Okay, this cone surface where this theta is fixed, that is 30 degree. So, let's take this cone out. In xyz plane we have taken this. Now what is what will be the area element for this in the spherical symmetry? So first let's write the range. R will go from 0 to r. Theta will go from 0 to 30, that is pi by 6. This theta is fixed. Now phi will go again 0 to 2 pi. Now see, we have two surfaces here. First is this curved surface, second is this circular surface. Now for this surface, what is fixed? This r is fixed. So dr equal to 0. So when dr equal to 0, then you can write directly from here. R d theta, r sin theta d phi will give you area element. It will be r square sin theta d theta d phi. So you can write the surface element or the area element same as you did in the previous ones. Okay. Now for this curved surface, what is fixed here? Theta is fixed, that is pi by 6. So what will be 0 here? D theta equal to 0 and direction will be theta cap. In here the direction was r cap. So here theta is fixed for this surface, curved surface. So d theta equal to 0. So area element will be dr r sin theta d phi. So r sin theta dr d phi will give you your area element and direction will be theta cap for this one. Okay, so that's how you can find. In the spherical symmetry also we can have dot product and the cross product, just like in the Cartesian symmetry. This was the case in the Cartesian symmetry. X dot x cap equal to 1 and same for y dot y and z dot z. And when you have the x dot y, they are perpendicular to each other. That's why we are getting 0 here for all of them. And for the cross product for the same vectors, the angle is 0. That's why we are getting 0. Sine 0 equal to 0. And if you have this kind of system and x cross y will give you z, y cross z will give you x, and z cross x will give you y. So you can see this, you can remember from here, xy will give you z, zx will give you y, and zx will give you y, and xy will give you z. That's how you can remember this. Now same you can apply in the spherical symmetry also. So here r dot theta, phi dot phi equal to 1. Means this is same case because now you have the r theta phi as your 3 axis system. So you will apply the same rule as you applied here. So we will have the same result. And again you can write cross product in terms of this r theta phi. So r cross theta will give you phi cap, phi cross r will give you this, and theta cross phi will give you r. So that's how you can remember this. So let's see the third symmetry, that is cylindrical coordinate system. So in cylindrical coordinate system we represent any vector in this form r phi z. So any vector can be written in this form ar cap, a phi cap plus a z cap, where these r cap, phi cap and z cap are representing the directions, means the length or distance in that direction. Okay, means we need to find that. Okay, so first let's specify what are r cap, phi and z here, r phi z here. So here in the cylindrical symmetry, first write the x y z, then in terms of this we can find the r phi z. So see, you made a cylinder around this z axis as your axis, z axis as your cylindrical axis. So you will like this, make the cylinder like this. Then the radius of the cylinder represents the r. Then this plane made by this r. Okay, and the angle made by this plane from the x-axis will give you phi, and this z means length of the cylinder or the height of the cylinder will give you z. So point P lies on the surface of the cylinder. So coordinates can be given. R represents the radius of the cylinder. Phi is the angle made by the plane containing radius vector r. Makes an angle phi with the x-axis, and z is the cylindrical axis. Okay. Now what is the ranges of them? So r is going from 0 to infinity. It can go from anywhere, 0 to infinity. Phi can go 0 to 2 pi, just like this. But z can go from minus infinity to infinity, because this is a single axis. You can represent the length in terms of minus infinity to infinity, any value. Okay, so that's why we are getting these ranges. Now see, you can represent in terms of x y z, these r phi z. How? This x coordinate will be, this one will be, if this is your r, then it will be r cos phi, and this will be r sine phi y, and z will be z. So that's how you can see them in the Cartesian coordinates also. Now how we represent the line element or the change in the vector in this coordinate system? So dl is r phi z, so it will be r plus dr, phi plus d phi, z plus dz. Now to represent them in the terms of length, because we need to find this length change in terms of phi, means we need to find the length change in direction of phi cap, length change in terms of z direction, and length change in the direction of r cap. So r is simply again length, so change in this will be dr. So that's why we will write here dr. In here z also the change will be dz, so we write dz here. But what will be the length change in phi cap direction? So phi cap direction will be this. Now length change will be, means you can write this, if phi is changing to d phi, then length will be this one. So you can write this one as this. So this is r and change it d phi. So this is theta equal to L by r. You can apply that rule, that arc will be r d phi again. So change in length here, it will be in the direction of phi cap will be r d phi. So that's how you can write your line element or the length element here, dr r cap, r d phi phi cap plus dz z cap. Now you have length element. Now here, if you can write xyz in terms of r phi z, you can write again r phi z also in terms of xyz, because this r is nothing but x square plus y square. From here you can see, and phi is tan phi will be y over x. So it will give you phi will be tan inverse y by x, and z will be z. So that's how you can find r phi z from x y z. Now we have line element, we have this thing. Now we can write the volume element and the area element for this. So what will the volume element? So you have the length change. Now you can, these are also perpendicular to each other, r phi z. So they will make a cube like structure. So change will again given by multiplying all these changes. So dr r d phi dz multiply will give you volume element. So it will be r dr d phi dz. So remember this, for the cylindrical coordinate system, volume element is this. Now what will be the area element? So it depends on the different kind of surfaces. Just like first we take a simple cylinder and find the area element for this. So how many surfaces we have? We have three surfaces. One at z equal to r or z equal to l length. Second surface is at z equal to 0. And third is this curved surface. So let's write the area element for all of them. Here limits will be, r will be going from 0 to r, phi is going from 0 to 2 pi, and z is going from 0 to l. See, we can write or make this graph, make this cylinder in that way also, means take this origin to the middle. Then what will be your ranges? Then z will go from minus L to L, and phi and r will remain same. So that's how you can imagine this. It can go in the negative also, the z one. So let's write for this one. So first we will write for this curved surface. So for what will be fixed for this curved surface? That is r. So dr will be 0. So you can see from here, this dr will be 0. So area element will be r d phi dz, and direction will be r cap. So any element on the surface will be equal to, surface element will be r is fixed, that is r capital R d phi dz r cap. Now for this one, this surface length is L. So what will be fixed here? Z will be fixed. So dz will be 0. So it will give you r dr d phi, and direction will be z cap. Same for this z equal to 0. Direction will be in the opposite direction because this is a closed surface, and outer perpendicular is in this direction. So you can get your area area element for this one is this, z equal to 0. So let's see the one more surface, that is quarter cylinder. So what is a quarter cylinder? Quarter cylinder is nothing but the 1/4 area of your, or the 1/4 part of a cylinder. So we have taken this. So this is your quarter cylinder. Now what will be the ranges of r phi z here? So r will go from 0 to r, phi will go from 0 to pi by 2, and z is go from 0 to l. So how many surfaces you have here? You have 1, 2, and this third is curved surface area, and fourth is this rectangle that side and that side. So you have total 5 surfaces. So what will be the area element for all of them? So let's see one by one. First, for this curved surface, again you know this r will be fixed. So dr equal to 0, and you will get the same, this r d phi dz, because this dr equal to 0, then r d phi dz will give you your curved surface, and direction will be r cap. So it will be same. Now for this one, what will be fixed here is it will be z. So dz equal to 0. So again you will get the same thing, r d phi dr d phi. and for this surface you will get this one. Now what we need to find is this one and this one. So what will be fixed for this surface? The phi will be 0, so phi is fixed, so d phi equal to 0. From here you will get dr dz and direction will be phi cap. So here is, so for this fourth surface you will get this. Now that was phi equal to 0 and phi equal to pi by 2. So for phi equal to 0 you will get the same area element, but direction will be in the minus phi cap direction, because this is your cross surface and outward perpendicular in this direction, and phi cap in this direction. So that's why for the phi equal to 0 you are getting minus phi cap, but for phi equal to pi by 2, this one surface, you will get plus phi cap. So these are same, just opposite in direction. So that's how we can describe all the 5 surfaces, okay, and the area element for all of them in the spherical, cylindrical symmetry. Now they also follow the rules, dot product and the cross product rules. So these are just same, because here also you have these 3 perpendicular axes, so they will follow these rules, okay, R5. Now let's see, sometimes we need to convert one coordinate system to another coordinate system. So how can we do that? So first let's study about the cylindrical and the Cartesian. So how to transform Cartesian to cylindrical or cylindrical to Cartesian? Means simply we need to change these coefficients in the and the r theta phi. So how can we do that? So let's say we have a vector in Cartesian coordinate system, that is ax x cap plus ay y cap plus az z cap. Now in cylindrical symmetry we have a vector as ar r cap plus a phi cap plus az z cap. So how can we transform this to this? Now see, a vector is same in both the coordinate system. So we can write ar as a dot r cap, because when you write a in this form, then after dot product you will again get ar. So that's why we can write ar in this form. Now in this a we can write this vector also, because both are same. So if you write this one, then you again get this one, but we don't need this, we need to convert. That's why we'll write in place of a this a. So when you write this one a, so it will give you ax x cap dot r cap, ay y cap dot r cap. So that's how you get this. Okay, so ar will be this. Same for a phi, you will write a dot phi cap. Now in place of a we will write this one. So again you will get this thing, and az is a dot z cap. So that's what we need to find actually, because we have ax ay az, we need to find ar a phi az. Then we can write r cap phi cap z cap in terms of this. So this will be your formula to find this. Now to find this thing, we know ax ay az, so we can substitute ax ay z, ax ay az, we can substitute these things here. But we don't know this x dot r cap, y dot r cap, z dot r cap, all these things. So we need to find them first. So let's see a table which will give you all of them. Dot product of all these terms means x, y, z and r phi z. So this is your table, you need to remember. But how to get this table, let me tell you. So here is x dot r cap. So here you have coordinate system, so x, y, z, and if this is your plane, then it will be r, phi and z. Now let's see these dot products. So x dot r, x is in this direction and r is in this direction and angle is phi. So dot product is nothing but magnitude multiply cos phi. So magnitude are 1 because these are unit vectors, so it will give you cos phi only. So that's how you get x dot r is cos phi. Now y dot r, so y is this and r is this angle is 90 minus phi. So cos 90 minus phi is nothing but sin phi, so you will get your sin phi here. And again, now z dot r, so z in this direction, r in this direction, they both are perpendicular, that's why we are getting 0 here. Now x dot phi cap, so this is x direction and this is phi direction. Now see, we need to find the angle between x and phi. So see, this is 90 and this is your x direction, sorry, this is your x direction parallel to this, and this angle is phi, this angle is 90. So x and phi, angle between x and phi will be 90 plus phi. So you will get x phi cos 90 plus phi. So cos 90 plus phi will give you minus sin phi. That's why we are getting x dot phi as minus sin phi. Now y dot phi cap will be angle between y and phi. So see, this angle is phi, this is 90, and what will be the angle between y and phi? It will again be phi. So how we find it, this angle between y and phi? So see, if you assume this phi direction, then it will be in this direction phi, and the angle between this x and y will be 90 minus phi here. Now this r and phi will be perpendicular to each other, So if it is 90 minus 5 and this is completely 90, so 90 minus 90 plus this will give you phi angle here. So angle between phi and y will be phi. So that's why we will write cos phi magnitude will be 1. So y dot phi will be cos phi. Now z dot phi, z is here and phi is here, so they are perpendicular to each other, so that will give you 0 here. Now x dot z is again 0, y dot z is again 0, but z dot z is 1. So that's how you received this table. Okay, now you remember this table because with the help of this you can simply convert your Cartesian coordinates into the cylindrical and cylindrical to Cartesian. How? Now we know the values of them also. Means in place of x dot r, you can write cos phi, and in place of y dot r, you can write sin phi. In place of z dot r, you can write 0. So that's how you can convert. You can find ar from that, and you can a phi from here and az from here. Then you have ar a phi z. Then you can just place them here. Then you have a vector in the r phi z. So let's take an example. In Cartesian coordinates, a vector is given as x cap plus y cap plus z cap. Now to find the AR, what you will do? You will do A dot R cap. That will be x dot R cap, same as here. Now you know AX, AY, AZ are AX, YZ simply. Now x dot R is cos phi, y dot R will be sin phi, and z dot R is 0. But see, these x, y, z also should be turned into the cylindrical coordinates. So we already know this x is nothing but r cos phi and y is r sin phi and z is z. So I write it here. So in place of x, y, z you will write them also. So in place of x it will be r cos phi, and then x dot r will cos phi. So that's how we get this. Now after solving this, you will get here, it's like r cos square phi plus r sin square phi. You will take r common, then that will be 1 here. So ar component nothing but r. Same you can find a phi, that will came out to be 0. A phi will be nothing but a dot phi cap. So a will be this, and phi cap, then dot product will give you your values. In the last you will get 0 here. Same for az, you will get z. Now you have all the three components ar, a phi, az. If you have all these three components, you can write simply your a vector in the cylindrical coordinate system. How? That will be ar r cap, that means r cap, then this a phi cap, that is 0 phi cap, and then it will be az z cap, that is z cap. So simply your vector in the cylindrical coordinate system will be a equal to r cap plus z cap. So because these are your coordinate system, means coefficients, so you now get your vector in the cylindrical coordinate system. That's how you can get this. Now similarly you can also go from cylindrical to Cartesian. How? Then ax will be a dot x cap, and in place of a you will write this vector. This just a similarly you can follow this. Means here we have written ar equal to a dot r. Now if you have ar already, then you can find the ax, that will be a dot x cap, and then a will be this vector. Okay, so you can go in the reverse similarly. Then ax will be a dot x cap, and a is nothing but this, so it will give you r dot x cap plus z dot x cap. Now you can find this r dot x cap from here, that will give you cos phi, and here you have r and this. Now you know r is what from here. So the result will be r cos phi from here and 0 from here. Now see, this r cos phi is nothing but this is r, then r cos phi gives you x simply. So in place of r cos phi you can write x. So you will use this relation in everywhere. When you have x, y, z, you can use them to get this r phi. When you have r phi, you can get use them to find the x, y, z. So in place of r cos phi we will write x. So ax component will be x. Same for ay, it will be a dot y cap. Then you will find it. You will get y again. You can try that. Az will be a dot z cap. You will solve that, you will again get z. Then x, y, z will be your ax, ay, az. Then you can write this vector in this form. So you get this reverse. Okay, now you have your Cartesian coordinate from the cylindrical coordinates. That's how you can transform easily. So that's it for today. In the next lecture we will see the spherical to Cartesian. Okay, that will be also be same, but let's see. Thank you everyone.